Hi, in this presentation, I'll be talking about the language server I've been developing for TableGen. First, let me briefly explain TableGen. It's a domain-specific language used within the LLVM project. Specifically, in LLVM, it's used for defining LLVM backends, ML dialect, and ground CLI options. The scale of code written in TableGen is substantial, over 1,500 files containing more than 870,000 lines of code. This clearly demonstrates how TableGen has become one of LLVM's core components. Now, how is TableGen used more specifically? Here, we use the RISC-V backend as an example to explain. The core file for the RISC-V backend is RISC-V-td. Within this file, and any file it includes, you'll find definitions for RISC-V registers, instructions, their byte encoding methods, and other related specifications. For instance, in the code currently displayed, you'll see definitions for both the add and sub instructions with their encodings, opcodes, and properties. During build, the TD file is processed by LLVM TableGen. This tool parses the TD file and executes multiple specialized backends to generate code. These backends produce C or C++ code for components such as assembly writers, register information, and sub-target information. Then, these generated files are included from other source code and used as a part of the RISC-V backend implementation. Now, let me briefly explain LSP as well. LSP is a protocol designed to provide code analysis features from language processor to editors and IDEs. By using LSP, editors and IDEs can easily implement features like code compression and go-to definition. In recent years, numerous language servers have been implemented and are in widespread use, including CloudD and Rust Analyzer. Of course, language servers for TableGen have also been developed as LLVM's official language server. TableGen LSP server has been under development as part of MLIR since 2022. However, this language server faces several challenges. First, the number of implemented language features remains limited. Currently, 5 features are available: diagnostics, go-to definition, find reference, document links, and hover. However, features like auto-completion, outline view, and refactoring tools have not been implemented yet. Moreover, no new feature development appears to have occurred since 2023, with operations primarily focusing on bug fixes and refactoring. Second, when working with large TableGen code bases, the language server may exhibit slow response times. This is because the server parses and analyzes all files every time you edit code in the editor. In the worst case, it may take up to a second or more to receive responses after making code changes. Additionally, the language server can be unstable. Opening files containing fatal errors may cause the server to crash. This occurs because the CLI-based LLVM TableGen parser is reused here, which is implemented to abort the program upon encountering errors. Third, it cannot handle the include anti-pattern. It is common coding patterns in LLVM backend code. Let me explain this with a figure. Imagine a scenario with 3 files. First, a file named RISC-V-td that includes both target TD and RISC-V register info TD. Target TD defines the register class, while RISC-V register info TD references this register class from a class called RISC-V reg. Now, imagine opening RISC-V register info TD in an editor. In this scenario, the contents of RISC-V register info TD do not provide information about where the register class is actually defined. As a result, the editor cannot resolve the register class from target TD, leading to errors. This type of single resolution issue caused by specific include pattern is referred as the include anti pattern. To summarize, the following requirements must be met for the TableGen language server: modern and full features, fast, error-tolerant parsing and analysis, and support for the encrypted answer pattern. To address these needs, I am developing a new language server for TableGen called TableGen LSP. Let me explain its three key features. The first feature is enhanced support for more language features. In addition to the language features implemented in TableGen LSP server, I have added functionality including count completion, code folding, inlet hints, and outline view. The second feature is our implementation of incremental and error-tolerant parsing. For implementation, I use the Rowan and Salsa libraries adapted by Rust Analyzer. Rowan is a library for implementing red-green trees, which allows us to construct syntax trees even for code containing syntax errors. The primary difference between abstract syntax tree and red-green tree is lossless. In other words, red-green trees preserve all trivial code elements like comments and white space. Salsa is a library for implementing incremental processing. More specifically, it caches parsing result and analysis data, reducting the need for recomputing whenever source code changes. The third feature is functionality specifically designed to handle include answer patterns. Users can specify a source root file, ensuring that analysis always begins from this root, regardless of which files are currently open in the editor. To illustrate with the previous example, suppose RISC-V-TD is specified as a source root. Even if you open RISC-V register inf-TD in the editor, analysis will start from RISC-V-TD. This enables us to obtain information about which files are included, allowing proper restoration of reference such as register class definitions. Let me describe the architecture of TableGen LSP. The language server is implemented in Rust. It consists of three modules, the LSP server, parser, and analyzer. Currently, with no dependencies on LLVM, we have also implemented a VS Code extension that enables users to use the language server's functionality. Future works. My primary goals are to expand support for additional TableGen syntax. Since I have implemented the parser and analyzer myself, it currently lacks support for some syntax features like multiclass and LLVM. Additionally, I aim to integrate with LLVM original TableGen implementation. This is particularly important for diagnostic purposes, as accurate error information will be necessary for proper error reporting. I also plan to implement further language features such as range support and semantic highlighting. In conclusion, I am developing a new language server for TableGen, TableGen LSP. It is available as a VS Code extension and can be used by anyone. I sincerely hope you will give it a try and share your feedback. Thank you.